Hello everyone, I am Rahul. In previous video we have discussed the basic numericals of the Nernst equation. In this video I will take two different aspects of Nernst equation. In first aspect we will take an example of the electrochemical cell in which out of two electrode, one electrode is the gaseous electrode. One electrode is the gaseous electrode and in the second aspect we will try to explain we will try to calculate the Kc, value of Kc, that is the equilibrium constant. Let us first understand how to do cell notation or how to represent cell whenever you are provided with a single gaseous electrode. You are a set of electrochemical cell. In electrochemical cell you have two beakers. In single beaker oxidation takes place and in other beaker reduction takes place. In other beaker reduction takes place. In one beaker you are provided with the electrode dipped in its electrolyte. In second beaker you are provided with electrode dipped in electrolyte. Okay? But now the case is a little bit different. Why little bit different? Because I am taking a one electrode, a gaseous electrode. Hi, gaseous electrode कौन सी? Yes, you are thinking right, beta. Hydrogen electrode. Which electrode? Hydrogen electrode. Hydrogen. Whenever you are provided with a hydrogen electrode, there is a change in the representation of cell. We will have to little bit change the representation of cell. How can we represent the cell whenever you are provided with the gaseous electrode? Whenever you are provided with the gaseous electrode, let us take the example of a simple cell. In left side or anode side oxidation takes place, whatever may be the concentration, suppose it to be 1 molar. Copper 2 positive, 1 molar copper. We represent cell like this. But let us suppose on the right hand side, on the cathode side, you are not provided with the copper, you are provided with what beta? You are provided with the gaseous electrode, standard hydrogen electrode. Gaseous electrode, standard hydrogen electrode. I think this representation is known to everyone. But on the cathode side, left hand side, you are provided with zinc dipped in a zinc sulfate solution, that is 1 molar at 298 Kelvin. And on the right hand side, you are provided with the standard hydrogen electrode. Which electrode? Standard hydrogen electrode. How to represent the cell in that case? How to represent the cell in that case? Let us discuss. On the left hand side we are provided with the same. On the right hand side, how can we represent cell? Okay, it is very simple. H positive, 1 molar, H2. But here is gaseous, we will have to mention the pressure over here. Let us suppose it 1 bar, which is a standard, and it is in form of gas. Now this is the wrong beta. This is wrong. How this is wrong? Let us discuss. Beta, there is a transfer of electron. We need a surface. We need any surface to do transfer of electron, to do exchange of electron. How transfer of electron takes place without any surface? Here there is not any surface. We need a surface to do transfer of electrons. So we will have to use a metal. We will have to use a substance which is a sort of inert type, which merely do what? Helps in the transfer of electron, do not take part in the reaction. What we need is, we need a surface that helps in merely transfer of electron but do not take part in the reaction, and that may be the, you know very well, platinum. That may be the platinum. Why we use platinum over here, beta? Platinum is an inert substance. It merely helps in the transfer of electron. Do not take part in the reaction. So before writing H2, I will have to mention platinum over here, and platinum is a solid surface and it provides surface for the transfer of electron. And I will have to write platinum over here. There is no other way. I have to use this. Now here is H2. Let us suppose pressure is 1 bar. This is how we represent cell whenever you are provided with a gaseous electrode. Now I am giving you a cell, or if I am saying ki you can calculate easily Nernst EMF of cell when you are provided with a standard condition, that is the 1 molar concentration of electrolyte, and you are given with the second thing is 298 Kelvin. But whenever concentration is different, you will have to use what? You will have to use the Nernst equation. Now let us discuss how can we apply Nernst equation in it. You are given with this cell, cadmium solid, cadmium 2 positive, let us take it as 0.01 molar, 0.01 molar. Salt bridge, here I am taking H positive, and concentration of H positive is 0.02 molar. Directly I can't write H2, I will have to use platinum over here. Platinum over here, what is the role of platinum over here? It helps in the transfer of electron. It helps in the transfer of electron, and here is H2. Here is H2. H2, and let us suppose pressure of H2 is 0.8 atmosphere. Yani ki conditions are not what beta conditions are not standard. Conditions are not standard, and E naught SRP value for cadmium 2 positive cadmium is minus 0.40 volt. Calculate the EMF of cell. Oh my god. EMF of cell. Whenever you are provided with a different concentration, one thing that directly comes into mind, we can use the Nernst equation. We can use the Nernst equation. Now let us apply the Nernst equation. Kya? E cell is equal to E naught cell minus 0.059 upon N log of anode upon cathode. Wow. If the cases are so simple, then there is no need to take the different aspect. There is no need to take the different aspect. Case is not simple. Why so? Let us discuss now. There is a E naught cell. There is a E naught cell. How can we calculate the E naught cell? We are provided with only cadmium 2 positive cadmium. We are given with only a single electrode potential. How can we calculate the E naught cell? How we can calculate the E naught cell? E naught cell is E naught cathode minus E naught anode. And SRP value of cathode region, you know, hydrogen electrode, value of hydrogen electrode, standard hydrogen electrode, potential of the standard hydrogen electrode, that is the 0 volt. That is the 0 volt. E naught anode, this is the minus 40 volt. Then what is the E naught of the cell? Plus 40 volt. Yani ki we are come to conclusion with the plus 40 volt. E naught cell is plus 40 volt. What's about the N? How many electrons are exchanging over here? Let us discuss. How many electrons are exchanging? ठीक है बेटा, note down this. Why note down this? I will have to erase this. Value of this is a 0.40 volt. What beta? 0.40 volt. Now, cadmium is losing 2 electrons to convert into cadmium 2 positive. Simultaneously, H positive is getting 1 electron to convert into H. But we know very well that H exists in form of H2, so there is a exchange of 2 electron. How many electron? 2 electron. Okay. Now there is a exchange of how many electron? 2 electron. So value of N is equal to 2. Value of N is equal to 2. Put the value of N is equal to 2. Put the value of N is equal to 2. But dear ones, I will have to explain a little different thing to you. You will have to write the concentration of cadmium 2 positive over here, no doubt, because this is a electrolyte of anode, and H positive concentration over here, no doubt, no problem. But if you are provided with a gaseous electrode, think deeply beta, if you are provided with a gaseous electrode, there will be a certain pressure of the gas. There will be a certain pressure of the gas. If you are representing the Nernst equation as I am representing, means minus form, where anodic electrolyte is on upper side and cathodic electrolyte is on downside. What I am giving you the condition is, this is my framework. I am not using plus any time over here. I always use minus over here. I always use minus over here. Then if you are using like this, you will have to multiply the pressure. First of all, I will have to do the square of it. Why? Because in a balanced chemical equation, H positive comes 2 times. H positive comes 2 times. In previous video we have also discussed. Now simultaneously, what we will have to mention the pressure of the gas. We will have to mention the pressure of the gas on the upper side, on the lower side, where we will have to mention the pressure. If you are representing Nernst equation like me, if you are representing Nernst equation like me, you will have to multiply the pressure of the hydrogen gas over the anodic side. Over the anodic side. Which side beta? Anodic side. Simple beta. What you will have to keep in mind, if standard hydrogen electrode is behaving as a cathode, standard hydrogen behaving as a cathode, let us take a trick over here. Standard hydrogen electrode is behaving as a cathode. You will have to multiply the hydrogen gas, pressure of hydrogen gas in anodic region. In anodic region. Whenever you derive the whole concept, you can easily, but we will no need to derive this. Just keep in mind. We are just asked with the numericals based on it, pressure. Okay? Then here the standard hydrogen electrode is on the cathodic side. Here the standard hydrogen electrode is on the cathodic side. What you will have to do is, you will have to multiply the pressure. You will have to multiply the pressure of the hydrogen gas. Pressure of the hydrogen gas. Now we can easily calculate. E cell is equal to E naught cell we have calculated, that is a 0.40, 0.059 upon n log of cadmium 2 positive, concentration of cadmium 2 positive 0.01, and here is 0.02 ka square into 0.8. Into 0.8. Whenever you will solve this whole term, you will come with the value of 1.3010. सॉल्व कर लेना, आपके पास ये वैल्यू आएगी क्या बेटा, 1.3010, और इसको सॉल्व करके आपके पास आंसर आ जाएगा बेटा 0.63 वोल्ट. 0.63 volt. This is how you can apply the Nernst equation whenever you are given with the gaseous electrode. Whenever you are given with a gaseous electrode, let us now discuss the second aspect, and in second aspect we will discuss the question based on the equilibrium constant. Question based on the equilibrium constant, value of Kc. Value of Kc. You are given with a cell. Suppose this is 1 molar standard. What beta? Standard temperature is 298. ठीक है, मीन्स स्टैंडर्ड कंडीशंस दे रखी हैं आपको. टेम्परेचर इज 298. टेम्परेचर इज 298. ठीक है. देन व्हाट?